Good day everyone and welcome to another video. In our last video we talked about partial fractions and the linear method of solving partial fractions. Today we are going to be looking at another advanced level of linear method. We call it the repeated linear factor method. Now we're going to talk about partial fractions. So, the continuation of our previous video, partial fractions, and we're looking at the second method, the repeated linear factor method. Like the name suggests, repeated, so we are going to split both into half. So, like the name suggests, repeated linear factor method. We have linear factors. When linear factors are repeated, these are the kind of partial fractions we have. For example, let's take general formula for have x with the power a with the power of n. Repeated means it's raised to the power, like you're having a linear factor being multiplied by itself continuously. Okay, so we treat it as a over x starting from x minus a plus b over x minus a raised to the power of 1 plus c over x minus a raised to the power of 2 up to z over x minus a raised to the power of n. So this is the general way of solving repeated linear factor method. Let's take a V example. An example, I'm going to draw this from my head, so it could have some consistencies, but I'll try to be as realistic as possible. Okay, let's go with 5 over x squared minus 2x plus 1. Yeah, since it's going to be a perfect question, I'm going to illustrate everything we need to know about linear factor method. If this question was given to us straight as in this form, then we can solve direct. But I went to this form because many of these questions may come in this form. So we have to learn how to take from this form back to this and solve. Now, we're going to have to look at this because generally we have to check whether is it factorizable. That's the first question that comes to our mind. And if you check, this is factorizable. So if you factorize x squared minus 2x plus 1, check the sum of roots and product of roots. You should be having x minus 1 and x minus 1. So you can see that this is a linear factor and this is another linear factor being repeated. So we address this as 5 over x minus 1 squared. And bang, we have something that looks like the general formula. So how do we go about it? So my general formula says a over x minus 1 plus b over x minus 1 all squared. As n is raised to the power of 2, so we're going to go further. So having this, we have to find the LCM as per usual. So we have x minus 1 square. Basically x minus 1 goes into it, gives you 1, x minus 1, and then x minus 1 goes again, gives you 1 and 1. Having done that, we can now say that our lowest common multiple is x minus 1 squared. For those that really have understood the element of LCM, you should know that this should be the LCM of both of them. So you can go straight. So let's solve it like a fraction. We're adding fractions. So 5 over x minus 1 all squared is equals to the LCM, which have is x minus 1 all squared. So if you take this and you divide x minus 1, it's going to remain x minus 1. So times it by a, we have a into x minus 1. That's that. And then if you take x minus 1 square, in x minus 1 square, it's going to remain 1. And b times 1 gives you b. So what we're going to do is to compare both sides of the equation. Compare both sides. And to compare both sides, you can see this and this are similar, so we can eliminate them. So let's compare the numerator. 5 is a into x minus 1 plus b. So we have 5 into ax minus a plus b. So as usual, we're going to try to look at the coefficients of x and also look at the constant. So like we did in the first video, we're going to assume that there's an invisible 0x, since 0x adding to 5 gives nothing, because 0x is still 0, 0 plus 5 is still 5, and we're going to assume ax minus a plus b. So what's the coefficient of x? Comparing both sides, you can see that coefficient of x here is a, coefficient of x here is 0, so a equals 0, and for the constant, the one that has no coefficient, you have minus a plus b equals 5. Okay, let's take this as equation 1 and equation 2. So we're going to put 1 into 2. So we have a equals 0 from 1. So we're going to have minus 0 plus b equals to 5. Minus 0 plus b means b, so b equals 5. And we have been able to successfully solve linear factor method. So please do well to subscribe to our channel and like the video, and also follow us as we're going to drop the last and final method, which you get to find out where we'll do our next video. Please share, subscribe, comment. Anything you don't understand, just comment. You could hit me up on WhatsApp, 08113747563. That's my WhatsApp number. You could hit me up with any of your questions. I will surely provide answers to them. Thank you, and see you in our next video.